welcome back to another video of PPS by Jai Balaya series. So today we'll be discussing about one of the most important topic, recursion. Okay, recursion is one of the most complicated topics that you may encounter in C programming because the tracing method is completely different than what it is till now. Okay, so first of all, let's understand what is recursion. If you have a function called as int add of two numbers, that is int a comma int b, just as an example, don't take it seriously, and there are n number of functions in the return statement. If the function is itself calling it once again, if the function is calling itself again, this particular type of problem is called as recursion. That is, function is calling itself inside the function. The same function is calling itself again and again and again and again and again and again. And one of the best examples to represent recursions is nothing but looping statements. If you remember the looping statements, for loop, while loop, do while loop, in the same way they were also repeating themselves again and again until a set of constructions or instruction or some termination statement was executed. This is also same type of problem where the function will itself call itself again and again until a condition gets satisfied. This type of problems is called as recursion. Okay, this is recursion, function calling itself inside the function body. So let's try to understand this with an example. So let's write a C program. That will print first n positive numbers, in decreasing order. That is, if we pass the parameter as 5, it should print 5, 4, 3, 2, 1 using recursion. Okay, this will help you understand it better. So let's see here. Hash include stdio.h. okay, int main. Let's go to the main function, and in the main function let's call the recursive function, that is my printing function nat, which stands for natural, and I'm passing the number 5. Okay, I'm just passing the number 5. So see here what happens. My nat function, int nat, is nothing but taking an integer number of int a. Okay, I have to print it in reverse order. So printf percentage d comma a. That's it, right? I printed the number, so this will print me 5. So now I have to get 5, 4, 3, 2, 1 as well. So what I'll do is I'll return, in the return function I'll again call the nat itself, nat, and I want to print the 4 next, so it is a minus 1. I'm decrementing the value of a. That's it. So what this function does is, this is the simplest function, this is a recursive function. So see here, initially nat of 5, that is 5 was passed, it printed the value 5, and next time we are calling nat of 5 minus 1. Okay, nat of 5 minus 1. So what this will print is, this will print 4, and again it will call for the function nat of 4 minus 1. What this is gonna do, it is gonna print 3, and again it's gonna call the function nat of 3 minus 1. Next time this is gonna print 2, and it's gonna call another function nat of 2 minus 1. This is gonna print 1, which is the first natural number, and the execution should have stopped here, right? The execution should have stopped here, but if you observe this condition, there is no termination at all. There is no termination. This is also something like an infinite loop. This is an infinite recursion. It will call for nat of 1 minus 1. It will print 0. Again it will call of nat of 0 minus 1. This is called as infinite recursive problem. To come out of the recursion, we should have some set of functions. Like if you take a for loop, for I is equal to 0, we have something like I is less than 10 or I is less than 20, when for loop will end. In the same way, recursion doesn't end in that pattern, but recursion can be ended in a different way. So I'm writing the same nat function, but this time I'll make a small change. Okay, see here, the first number it is gonna print is the given n number, and the last value that it should print is 1, because the first n natural numbers in decreasing order are 5, 4, 3, 2, 1. That's it, right? So you have to check multiple conditions. If a is equal to 1, that is, let's assume we did so many iterations and now we are here, we reached here. If a is equal to 1, what you need to do is print the value of a, percentage d, and print the value of a. Now return 0. You people know, right? Return 0 means end of the execution. Or else there may be one more condition. Else if what is the user by default, instead of passing a positive number in nat of 5, he passed something like nat of -5, or he passed something like nat of 0, which are illegal. So else if a is less than or equal to 0, you have to check if the condition is true or false. Printf invalid number. You have to print it as well. Invalid number and return 0. We are ending the execution here itself. If in case we get 1, we'll print the value and close the function. If in case the user entered 0 or -1 or -5, something like that, we are showing invalid. Else call the return function. Before return, write printf %d space a, print the value of a, then call return of nat of a -1. That's it. Nat of a -1, and this closes my function. So see, now we have two termination conditions. Let's try to trace this program with this example. It passes nat of 5. We got nat of 5 here. Now is 5 equal to 1? Is 5 equal to 1? No. Is 5 less than or equal to 0? No. So we'll print the value 5, and then we are gonna call the function nat of 5 -1. Now come here. Now check. Is 4, now a is 4. Is 4 equal to 1? Again no. Is it less than or equal to 0? Again no. So print the value of 4. Again call nat of 4 -1. Now it is 3. 3 is neither equal to 1 nor it is less than 0. Print nat of 3. Then call nat of 3 -1. This is how you have to trace a recursion. Next time nat becomes 2. It again calls for the function nat of, nat of 2 -1. Again you call the recursive function. Now it is 1. See here, it is 1. We printed. Now what happens? A became 1. If a is equal to 1, printf % the value of a. We printed the value of a here. Next, what is the condition? Return 0. This will return 0 to the main function. This will return 0 to the main function, which means the termination ends here. We are not calling the return function again. We are ending the termination. So what did we print? We printed 5, we printed 4, we printed 3, we printed 2, we printed 1, and we terminated. This kind of problem where the function calls itself again and again and again and again and again is called as recursion. Okay, this is one of the important types. I'll give you one more example for recursion. Let's try to find GCD of two numbers, greatest common divisor of two numbers. Before writing the function, I want to show you something. There is something called as Euclidean method of finding GCD. Euclidean method of finding GCD. This is the most simplest form of calculating a GCD. That is, if there are two given numbers, say a comma b, you just have to keep on calculating. First you have to pass the parameter b, then you have to calculate and pass the parameter of a by b to the next function, until and unless a modulus b becomes 0. If a modulus b becomes 0, this first parameter will become your GCD. I'll demonstrate it. See here. Let's find GCD of 10 and 3. Okay, 10 and 3. According to the condition, what I should pass in next time, I have to call the function GCD again, but this time pass this as first parameter and calculate 10 modulus 3, which is 1. 10 divided by 3, the remainder is 1. Pass it as the second parameter. Now calculate the GCD again. Now 1 comes here. We have to calculate 3 modulus 1, which is equal to 0. 3 divided by 1 is 0. As I told, if we get 0 here, we have to stop here, and this number becomes GCD. So GCD of 10, 3 is equal to 1. That's it. This is Euclidean method of doing this. Formula is very simple. You keep on passing the second number first. If there are n1 and n2 two numbers, in the second iteration you have to pass n2 comma n1 modulus of n2 until this number becomes 0. If this number becomes 0, n2 is your GCD. This is the concept Euclidean gave, a great mathematician. I'll show you again. GCD of 20, 5. Let's assume 20, 5. What am I passing? I am passing n2 first, 5, and I am then passing 20 mod 5. 20 mod 5 is 0. You can see here it became 0. We have 5 here. So nothing but 5 is the GCD. That is GCD of 20 comma 5 is equal to 5. Okay. I hope this is clear. So now let's write the recursive function. That is int GCD int A comma int B. Now let's write the termination condition first. If this number, if it becomes 0, we have to terminate. If B is equal to 0, if B is equal to 0, printf GCD is equal to %d. We have to print this as the GCD, right? According to the formula. That is what Euclidean gave to us. %d, A is the GCD, return 0. Return 0. End the program. Else this means that B is not 0 yet. B has some value like 5, 4 or some value. What should we do? We have to return or call the function return GCD of call return function GCD of what is it? First pass the second number B, then pass A modulus B. Done. Close. This is the recursive problem. This is the recursion problem to print GCD of two numbers. That's it. Recursion is this simple. You just have to understand how to end the program. Let's trace this. Let's say I pass two numbers, GCD of 30, 7. Let's assume I pass something like GCD of 30, 7. Initially 30 comes here, 7 comes here. Is 7 equal to 0? No. What should I pass? I should pass B to B first. 7, 30 modulus of 7. 7 3 is a 20. What will be the answer? 7 3 is a 21. 7 4 is a 28. 2 will be the remainder. Right? 2 will be the remainder. Yes or no? 2 will be the remainder. So now 7 and 2 are gonna come here. Sorry. Yes. 7 and 2 are gonna come here. Is 2 equal to 0? Is 2 equal to 0? No. We are again calling the GCD function. This time 2 comes here and 7 modulus 2. What is the answer of 7 modulus 2? Remainder is 1. So 1 comes here. Again GCD function is called because this is not 0. GCD of 1 comma 2 modulus 1, that is equal to 0. So it becomes 0. Now this condition satisfies. We print the GCD as GCD equal to %d of A. A was nothing but 1. So GCD becomes 1 and we end the termination. So this is how you trace a recursive problem. This may look difficult for you people at first attempt, but if you keep on trying, you will get a knack of it. See, tracing a recursive problem is not that simple. It's not like you wrote I is equal to 1, n I is less than n, I plus plus, and tracing like for a table. This is not a loop. You can't trace it like a table. You have to trace it in this manner. Okay. So this is another recursive problem to find the GCD of two numbers. This is a Euclidean method. I want you people to first practice Euclidean method using pen and paper. After that, write the program. This is the simplest program. See, GCD int A comma int B. If B is equal to 0, A becomes, this particular thing becomes the GCD. End it there with return 0. Else return GCD, call the recursive function again. Remember, to terminate a function, you always have to return anything other than the function name. If you return a function name, the function is gonna get called again. But if you want to end the function, you can return 0, you can return 1, you can return any number, you can return any value, you can return any expression, anything is possible. Even you can return -1, -2, etc. But never ever return a function name again. If you return a function name again, instead of terminating, you are calling a new function call, and again that particular thing will be executed. So to exit from a recursion, you always have to end it with a value. Is it clear? So if this much is clear, we are done with recursion. So in this problem, I showed you how to calculate GCD using recursion because this is an important problem. I want you people to try writing recursion for finding the factorial of a number. Try it yourself to find the factorial of a number. If not, if in case you get stuck, you can go to Geek for Geeks. There you will find the program for this. And understand, if in case you have any problems, like if in case you have any doubts, you can contact me at my Telegram ID. That is Pawan_Prakash_ VBIT. If in case you have any doubts in any topics that I have taught, I'll be more than happy to help you out. Okay, so have a great day. Bye bye. This is my Telegram ID. You can contact me directly here. I'll definitely help you out. Okay, Jai. Bye.